Hello everybody, my name is Halu. Welcome back to the series where we're dealing with programming and design patterns in Python. In today's episode, we're going to be talking about the singleton pattern, which solves a really interesting problem. So let me just start with what singleton is. Singleton is a design pattern which ensures that there's only one instance of a class during runtime. Okay, problem does this solve? What does this line mean? Okay, let's I want to paint this picture for you. Okay, let's say we have an application which is a game. Okay, and what this game application does is every morning it's more of a guessing game. Okay, so every morning the system, for example, it'll have one word that it'll decide. Okay, the users who connect to that game have a choice to guess that particular word. Okay, and this word is something that it'll pick randomly. Okay, now let's say I have a class called game. Okay, and I'm gonna, in its constructor, what I'll do is I'll have a set of words, and this will be a cat, bat, mat, pat maybe. I don't know, guys. I'm not able to think of complex words at the moment, but yeah, so we have 5 words over here. Okay, let's change this to something else, maybe oranges. Okay, so we have 5 words, and what the system will do is when I initialize this object, it's gonna pick a random word. So answer will be nothing but random dot choice of words. So I will import random also so that we can access this. I will take a random choice from this list and it'll store that. Okay, now I'll have a function called guess, and this will take an answer from the user. If we say if self dot answer equal to answer, we'll say print something like bingo, you guessed correctly, else print wrong guess, sorry. Okay, and we can probably print something like printf. We could do the system word would be something like self dot answer, and we can say your word is going to be answer. Okay, now this is my game. Okay, now what I'm going to do, I'm going to initialize a user, a player. Okay, so p1 would take a copy, I mean would access this game, and what p2 will also access this game. Okay, now p1 is going to attempt to guess an answer. Similarly, p1 will also attempt, so p2 p1, both of them are going to attempt an answer. P1 is going to guess orange and p2 is going to guess apple. Okay, so definitely one of these guys is going to get the answer wrong, because as we discussed, the game only sets one word for the day, and any user connecting to that particular game is going to be trying or attempting to crack this same answer. Okay, for example, you can think something like wordle. Okay, so users are going to connect regardless of how many users connect, the wordle is going to be the same. Okay, it's not going to depend from user to user. So you can see that so system word is bat in case 1, but system word is apple in case 2. And here you can see system word is changing, but just because I guessed apple, even though the system word is not supposed to be apple, it's either supposed to be bat in both cases or apple in both cases, one person gets the advantage and one person does not. So what is happening is, in systems like these, when you have multiple players or multiple people accessing that system, creating an entirely different copy. These are 2 different objects, by the way. I can just print them and show you what that looks like. You can close this out. You can see that this is a game object and this is also a game object, but the address of these 2 objects are completely different. That means this constructor is run again so that a word is created again, right? And you might think maybe this, I mean, this was the point about doing object oriented programming, right? Everybody can create their own object and therefore they run that constructor again. Well, not exactly. So when you're doing with object oriented programming, yes, I might need the features like inheritance, for example, where I can get different classes, inherit from different classes, whether it's their properties or their function, their attributes, all of that. So not necessarily every time I need to create a new object, but I need to still retain those core concepts. Maybe this example is something that you guys didn't understand. Maybe I can give you another example. Let's say I have a logging system in my computer, okay? And this logging system will keep track of all the application logs, and this will start at my startup every time I boot my computer, right? Now, regardless of which application gets access to these logs, they will always have the entire log sheet. It's not going to restart the logs and start from scratch just because an application requested, right? So this is one common place where, regardless of how many people access this particular object, it's going to give the same answer. So while we're dealing with a singleton, that's why we're saying that there's only one instance of a class in runtime. When you are running this, or when I'm getting this, actually I should not be creating a new object. Rather, I should be retrieving an already existing instance or already created instance of the object so that I can maintain that data. Okay, maybe again another example you can say, let's say you have an application, a delivery system, you're keeping track of orders, and then there are delivery people who connect to that application just to say what the orders are available, right? Now you have one machine or one list where you're keeping track of all of the orders. Now if everybody, let's say this delivery system is a class, if every single delivery person is accessing that class separately and creating new objects for every person, that list will be reset from scratch and they won't be seeing their deliveries. So you need to have one place where there's only one instance, and people who are accessing that will not create their own object, but rather just look at their instance. That is what singleton is, and that's what singleton aims to solve. Now I think there are three methods to create singleton, but we're going to be dealing with two main methods only, because that's the most simplest way to think about a singleton. Let's start with method one, and this is actually using decorators. Method one. Okay, and how this method one looks like in order to create a singleton, let's actually have our class singleton. Maybe we could create the same example again, right? This game example, right? So let us again, we can actually copy and paste this thing right here. Then I'm actually going to create class variable, something called as instance. I'll set this to none initially. Game dot instance will access this class variable and equal to self. Now what this means I'll explain in a bit, but yeah, in this method one, rather than us calling this like this where we're just instantiating, we'll actually call a class method called get instance. Okay, so that will look something like get instance of, okay, we don't need to add self because it's a class method, so we'll add the static method decorator. As I said, this method will deal with decorators. So how this will look like is we will simply check if this instance, right, is equal to none. In that case, okay, I should put game dot instance because you're accessing this class variable, right? If that is equal to none, what I will do is I will run this game. I will instantiate this, okay, because somehow there has to be one instance, right? So if there is no instance, create one instance is what we're saying. Now what happens is, think about this, okay, when I run this function, right, this part will run, correct, and then I am going to do this. Okay, so game dot instance is equal to self. What does self mean? Self means nothing but the object itself. So that is one instance. We are storing this object inside a class, inside a static variable or a class variable. Okay, so inside this instance will be this object, and whenever people are asking for this object, I will return it back to the user. Okay, so if that is there, this part right here where I'm creating the self will exist. What will happen if I do else? Now notice that we're not returning anything here, right? Instead of me returning, what I'm going to do is I am going to, when I run this function here, anyways, this instance will be populated with the latest object. So what I'll do, regardless of whether the user this if statement goes through or not, if it goes through, already this will be populated. If it does not goes through, then that means already an instance is there. So I am just going to go ahead and return this instance variable. Okay, I hope you're understanding why we're using this line right here, because in that case we can simply go ahead and return whatever is there in this instance. When we're running this, if it goes until this, I mean into this code block, it will go ahead and create and populate this variable for us. So in either case I can just return this game instance. Okay, now once this is done, let us go ahead and also add our guess method. Okay, because to show you guys what that looks like. Now that it's done, let us write the same driver code, except we're going to, as I mentioned before, in this first method, we'll not actually instantiate it like this. Rather, we will do game.getInstance. Okay, and this will be game.getInstance. I'm going to run this piece of code. You can see that in both cases, see, I have not initialize this at all. This is some different code. Okay, I have not initialized it. That means the first time when I run this, it actually goes ahead with this initializer. Okay, I can actually print init called. Okay, that makes more sense. You can see the first time when I do this, it calls the constructor. Okay, but the second time I do this, it does not call the constructor. I'm printing both of these objects, and you can see that these refer to the same memory address, which means that these refer to the same object. So my class is only instantiated once. This is a singleton. To prove more, both of these users are going to guess now. One user has guessed orange, one user has guessed apple. You can see in the both cases the word was cat, so it was only initialized once and it was stored, the word was stored. Okay, so regardless of how many users now access this, it will be common to all. And this is the use of a singleton. I hope you guys were able to get something out of that. Let's go ahead with method 2 now. And what is method 2? Instead of me doing this get instance, I am now going to directly call this and still have the same result. And that is method 2. How do you go to that? Well, again, very simple. I'm going to copy paste most of this. Maybe we could take this stuff. Okay, and I'm going to copy paste most of this. This is something that we'll be needing anyways, so I'm not going to touch that. I will take this out. Okay, in this there's a problem. In your init function, you can actually never return stuff back to the user, right? So we cannot use something like return game.instance when people are trying to call this init method. So how do you solve that? Well, actually what happens is in Python, before the init method is called, a method called new is called. And what does this new method do? This is the one that actually is responsible for creating the object, and it'll return the object, and this constructor is responsible for initializing that object. Okay, so I'm going to take this code out. Now let us actually define this new method and see what that looks like. So I'm going to do define new of class. Okay, this is because we're going to instantiate something like this. So what happens is actually the new method is called with passing our class as a parameter. So that is what is happening here. So what we will do here is, let's first print that this inside new method, something like this, because we can say that this method ran before our init is called. Okay, now we can then say if this class, that is whatever class we're calling, if that class has the instance variable already populated, so dot instance, we can simply go ahead and so now we can check that if this class, whatever class we're asking here, if the instance is none, in that case let's create an instance. Okay, and how you do that in method 2 will be a bit tricky to understand, but I'll try my best to answer that. One thing will be the same. We're going to assign this to the instance method, but how we'll create this would be a bit tricky. So what I'm doing is calling super. You know what super means? Super, it will be parent class. That's what super does. Okay, then I'm going to create new and of this variable. Okay, so what I am creating is, go to its parent class, from there use its new method to create an object of this class. Okay, so you might ask, what is game's parent class here when we say super? Well, actually all classes inherit from a class called object, and that's where you have this new method. So you're accessing the new method and you're creating an object. So this new method will actually return you the object, and the init method will initialize that object. So when I say returning an object, so now we are responsible for returning an object, an instance of an object. So let's go ahead and return this instance. So we can just return cls dot instance. I hope you're able to understand why we have this return comment and not inside some if block. If it is none, we'll create this, and when this is created, this will get populated anyways, and this will run. If it's not there, that means already that instance is there, it'll return. In both cases, that will hit. Okay, now I'm going to run the same driver code that we had here. Okay, and I'm going to do this. Now, what do you think will happen? Maybe this is a bit confusing right now, but we'll go back to this because this is very interesting, this bit. You can see that the inside method is called, the new method is called, which I told it'll be called before the init method, and the init is called. Now again it says in new method and init is called. So init is being called twice, the constructor is called twice, which becomes a problem. That should not really happen, is what I told you, right? Then but you see that the objects in both cases, both P1 and P2, they refer to the same memory address only, which is very, very weird. And then we get something like wrong guess, sorry, the word is the same. So initialization is being called twice, yet the word remains the same. How come? How is this possible? Well, to give you an answer, I'm going to do one thing. Instead of putting this P2 here, I am actually going to put this after we do game. Okay, and I'm gonna do this now. Okay, now see, in this case, again the address is same. Now the address is same because we are getting this instance variable, and that's how we are getting this new method creates. Okay, but the initialization for that particular object, so it's the same object address, but that same object address is initialized in two different ways. In way one, which is until here, what happens is it initializes the word as mat. Okay, and maybe I could run this again. Yeah, to show you what the difference would be like. You can see this is the same thing. You see, in case one, the word says cat, but in case 2, the word says apple. That's because it's initialized twice. That should not happen in our case, in our game, because that will be game breaking. Now, if I add this part right here, what is going on is, in this case, initialization 1 happens, and in this case, initialization 2 happens for that particular object, and whenever we are referring to the same object, it will have the same word. Okay, so if you're guessing after both initialization done, initialization 1 is basically ignored, and this is taken, and that's where the guesses happen. So regardless of how many times I run this, you can see that the word will always be same. That's why this is happening. So how do you prevent this problem? Let's again cause this problem so that we can have a better way of preventing this. So how do we initialize this? Well, just like in instance, we're actually going to create a new variable called init. Okay, and we'll set that to 0. Okay, this is a flag. Okay, let's set that to false for now. Right now, this instance is already created here, and this is populated, and regardless of whenever this init is called, this instance will always be populated. So what we'll do, we'll look at this init flag. Okay, so we'll say if game dot init equal to false, in that case alone, go ahead and initialize. So I'm gonna, in this case alone, initialize. Then what I will do is, once the init goes through, I am going to go ahead and set this flag to true. So the next time this initialization happens, once this new method goes through and calls for initialization, what happens is it says the flag is true now. It will not go into this if block, and nothing will happen. So I'm going to go ahead and run this. So you can see that 2 times init is called. I'm going to run this again. You can see that only 1 time it's called. Second time it goes inside the init, but none of the code gets executed because this if block fails, because our init flag fails. Okay, so here you can see again it's the same object as we discussed before, but it's also the same word. So regardless of how many times I run this, only once the actual initialization code would have gone through. So this word will always be constant. Now that wraps up what I had to talk about singleton. Now, this video may have been a bit overwhelming, especially the second method that we talked about. All of this what we're doing with super, why we are adding another flag here, why are we using this, why this constructor is called twice. All of that might be confusing for you, and I definitely do agree because when I started off and I learned this for the first time, it was also very overwhelming for me. So some things that you can do is you can watch this video again. Still, if you don't understand, you could probably leave a comment or look at more sources online to understand what this works like. But yeah, this is Singleton. I tried to explain this to my best of abilities. Maybe that went through, maybe that didn't. I don't know. You guys should let me know. Let me know some feedback down in the comments. Thank you so much for watching this video. If this video did help you, hit that like button. Now, this code will be available on our GitHub just like all our other videos. I highly recommend you to try this out on your own so that you get a grasp of what we are really doing here. Thank you so much for watching. I'll see you in the next video. Until then,